So first, good morning. Thank you all for joining us. I know some people may have had a big night last night. I know we tried to cut it a little short, but thank you for attending early this morning. We want to go through a couple things that we've been doing throughout 2019. So I do have the broader team that's been contributing with us. So my name is Paul Roberts. I'm a principal here at AWS that's been driving a lot of the contributions AWS is making. The team will also come up here in a little while to discuss the different initiatives that they've been responsible for. But just for context, Shalaka is one of our cloud developers. Allison is another software engineer who represents the ECS side. And then Sai is another cloud developer that's been helping with our deck and Lambda work that we've been doing. So I want to kick things off, and one of the questions that we get quite a bit is talking about why Spinnaker and some of the lessons that we've learned. I want to talk about what have we been working on, and then I want to talk about some of the community engagement and some of the things that we've been doing. And then lastly, I'm kind of going to be like the ShamWow guy where it's going to be, we're not doing just one demo, we're not doing 2 demos, we're going to be doing 3 demos. So hopefully the demo gods are going to be good to us this morning. So one of the questions that we get quite a bit is, why did AWS begin contributing to Spinnaker? And it happened last night. I get asked this all the time. And one of the big things that comes up is, well, AWS has CodeStar. So this is code deploy, code commit, code builds. We have other services that perhaps overlap with Spinnaker a little bit. But the main takeaway is that we really want to go where the developers are. And what this means is that there's a lot of open technologies that our customers are using. It could be Terraform, it could be Spinnaker, it could be something else. But we really want to go wherever they are. We want to make sure that the service adoption, the service integration with those respective technologies are frictionless when you're working with AWS. And roughly 2 years ago when we sat out to begin contributing to Spinnaker, we found that our services weren't exactly playing as nicely as they could with Spinnaker. So we wanted to fix that. And in terms of fixing that, we also wanted to educate the community about the things that we were doing. So the first thing that Netflix and the broader community shared with us is that you all need to update the documentation. Using AWS with Spinnaker is really difficult. So before we even wrote a single line of code, we really focused on fixing the documentation. Next, we began writing a number of blogs, and we'll dig into that. And then we've also been demoing a lot of this, and this year I was at AwsCon speaking about the work that we've been doing with Spinnaker. Later this year, I'll be speaking with Andy Glover at Netflix, where we're going to be talking about all the work that we've been doing together. So we're definitely getting out there and educating the broader community on our activities. And then lastly, maybe some of the most important things that we're doing is we're going through and we're fixing a lot of bugs with the cloud driver and various components within Spinnaker. So if there's things that you think that we should be taking a look at, we're very active on Slack. We're part of the AWS SIG, so we're happy to take any features, and we're constantly looking for ways that we can address and fix bugs and create new things for you all. So I'm going to hand it over to Sai, and Sai's going to talk about some of the lessons learned as we were going through this development process with that we've done over the past year. So Sai, why don't you come on up and share with the team.
Hi everyone, good morning. My name is Sai, and I'm a cloud developer with AWS. My role with this project was to orchestrate and organize between our front-end and back-end developers. And I'm here to share some of the lessons that we have learned in the last few months while we were adding this particular feature, Lambda functions, to our project, to Spinnaker. First thing is, I have a question for the audience. How many of you have found onboarding to Spinnaker to be super easy? Developers. Okay, so that's our experience too. So our developers have spent a lot of time trying to understand the architecture and then trying to get their local development set up so that they can start contributing. The big challenge was getting a proper local development environment with all the 8 to 10 microservices and having it work so that you can add a feature. And having appropriate developer onboarding documentation. So we found that was the main challenge when we were trying to contribute. And we did create some documentation on our end, and it will shortly be added, it will be released in the form of a blog post. But it's something which we definitely need to work on. For a new developer who walks in, it's a bit of a challenge to figure out all the different components that are there, where they need to add all the services that they need to edit to get a certain feature working. And our development team was spread across, like East Coast, West Coast, and one of the developers was in India. So it was a very interesting experience for me to coordinate between all the developers across different time zones and when they're working on different components. Like our front-end developer was there on the West Coast, and the back-end developer was like back in India. So having to coordinate between different time zones and different components, it was a very interesting experience. And the next thing was we needed to ensure that there's adequate testing, because when you change, for example, a certain functionality in Cloud Driver, you need to ensure it works through Gate, and also the same functionality is available in the deck as well. So that to integrate back and forth between all these multiple components was a very interesting experience, and we have learned a lot doing this process. And the next thing was we have also learned to make smaller pull requests. Initially, when we have started, we needed to go through a legal review for each of the pull requests. So our pull requests were really huge, like 20 files, 1,000 lines, and whatnot. So later on, we have educated ourselves to do better at that, and now our pull requests are much smaller, with only few files or less than like maybe 100 lines or whatever, very specific to the feature without trying to put together a lot of the stuff in one pull request. That's because of the legal requirements. We had to do that earlier because our legal needed to review each PR and make sure that there's no legal issues or any copyright infringements and whatnot. But now our Spinnaker has been added to a global open source initiative projects. That means we don't need legal review for contributing code to Spinnaker anymore. So we wouldn't run through that legal pipeline again. So the pull requests are going to be small from now on. And that's it from my side. Thank you very much. And I'll hand it over to Paul, who will walk through the next upcoming features, the updates that we made in 2019.
Okay, so I want to jump into some of the 2019 updates, and again, some of the things that we've done. So to date, we've written 5 different blogs about Spinnaker. So in the past, less than 2 years, we went from literally kind of doing nothing to now we have 5 blogs. We have a Kubernetes blog, we have a blog about Jenkins, we have a blog about our ECS integration. So some of this documentation, and so maybe this might be helpful. So if you want to go out there and Google AWS, Spinnaker, blogs, you're going to find a number of articles. There's another one that's in flight right now that's going to be talking about the work that we've been doing with Lambda. So next, what we're also going to be focused on is updating the Spinnaker IO documentation with the Lambda enhancements that we've been making. Last year, Claire did a lot of work adding the Fargate support into Spinnaker. And so for context, Claire Liguri is driving the AWS SIG, so we have these meetings frequently, and Ali, myself, and others are joining this. But the reason why I wanted to come back and highlight this is that Ali has been driving a lot of enhancements to Fargate. She's introduced artifact support to this, which she's going to be demoing a little bit later. And the reason why this is important is that it allows you to build really interesting dynamic pipelines. Next, Lambda enhancements. I don't want to give away too much just yet, but we've been focusing a lot with Lambda. We've heard a lot of interest from customers like Autodesk and others that they're interested in seeing Lambda support. When we committed the initial cloud driver about a year ago, last December, we began looking at everything that we did, and we actually found a number of bugs. And who would have thought some bugs in code? And we found some bugs. And so we wanted to go back and we wanted to refactor a number of things. But the other thing that we did was we didn't have VPC support as part of Cloud Driver initially. So we actually added a new feature which now enables your Lambda functions to run with the VPC, which was great. And so we did fix a lot of bugs. About 2,000 lines of code in total were written for this contribution, which going back to smaller PRs, we hear you, community. We're sorry for dropping these huge ones. We're really working to make them smaller. Okay, so community interactions. I just want to say thank you to the broader community. So when we created the cloud driver, we actually saw the Armory folks write a knowledge base article, which was super cool, and they shared with the community how you could actually create a Lambda pipeline through Deck. And they did this pretty early on. I want to say this was about 6 months ago. And then the other piece is I mentioned this a little bit with Claire, is that we are involved with the Aws Sig Meetings. So if you need to get in touch with us, if there's things that you think we should be focused on, please get into a Sig discussion. We're there quite a bit, and we have some really great discussions with the broader community. So next, I want to dive a little bit deeper into Spinnaker and ECS and what we've been doing with ECS in general, because we're hearing a lot of customers that they are using ECS. So number one, probably one of the coolest things, and Allie's here, and she's going to go in and she's going to demo this, is task definition artifacts. And really what this allows you to do is you can almost think about this as like a Kubernetes manifest file that's going to describe the task or the container or the containers that you're going to launch. So now this capability allows you to launch more than one container within Spinnaker, whereas before you could only launch a single container at a time. So now you could actually launch multiple containers. And Allie's going to walk you through all of this. Another great takeaway is that you can now enable these task definitions to be stored in some sort of artifact repository, so you can build this into your pipelines. You can treat these artifacts as code, and so you can make different changes as you need to. So this is a really nice feature. Next is service discovery. So anyone that's using a microservices architecture, service discovery is super important. So Allie did a lot of integration with AWS Cloud Map, so that is available now today. And then the other thing you can see here on the screen is placement constraints. Where are my containers actually going to live within the cluster? And so you can kind of control that. And this would be very similar to like Kubernetes labels and the placement strategy that you could use in that context. Okay. So touched a little bit on Lambda, talked about ECS a little bit. So what about EKS? And there's no major thing here. I think you all are aware that Spinnaker does work pretty well with Kubernetes. And EKS, there's no difference here. EKS works extremely well, and all the demos that you're going to see today are working on EKS. But the one takeaway that I want to share with you, we're actually starting to dog food a lot of the Spinnaker work that we're doing. And I mentioned at reInvent, we have a couple talks about Spinnaker, but we're going to be giving a workshop where we're building out an application that will be deployed with Spinnaker. So we're going to be talking at the workshop where we're deploying the application with Spinnaker, and we're also going to be doing a chalk talk talking about this. In this particular case, this was us scaling up to 500 pods. So again, we are trying to embrace Spinnaker as much as possible and use it quite a bit. All right, so getting into the meat of this. So last year, when we contributed Cloud Driver, everyone said, hey, great, you contributed Cloud Driver. Yes, there's APIs that you can use. But what about a UI? We really want a UI. Everyone said, we need to have this UI. If it's not there, it's not really important. So when we started thinking about this, we said, well, we don't want to just create a UI just for ourselves. We don't want this just to be Lambda specific. We wanted to create a new compute primitive that others in the community that have their own functions platforms, they could also leverage perhaps some of the work that we've done from a UI perspective. And so we actually began working with Netflix on what's the right approach, what should the UI look like, and so we began having those discussions. Greg Comstock was a great advisor for us while we were going through that, so thank you, Greg. So again, we thought about that this was a new compute primitive that we wanted to introduce. 2, this is going to be a new UI design for anybody, and anyone would be able to leverage it. And then 3, we wanted to work with the community, and so we engaged deeply through the AWS SIG, and we also engaged directly with Netflix to focus on this. So what does it look like? Doesn't it look great? Anyways, this was our first mock-up in Balsamiq, and so the first thing we did was we're like, what do we want this to look like? And Balsamiq is a great tool to mock up your basic UI designs, and so we had a big discussion at Netflix saying, this is kind of what we're thinking. Here's the general feel of what we want to do. And we went through a couple iterations, and by the end of it, we got pretty close to this. And so working with Greg and the rest of the Netflix team, they gave us some feedback on how things should look. But this is really where we ended up. And so we did add, this week, the deck code was merged, and what we're going to do here in a minute is we're going to walk you through using Lambda with deck directly. And again, you can see from a functions perspective that we didn't say, hey, this is Lambda, it's actually functions. So this is a new compute primitive that we were trying to introduce and make sure that the community could also use. So with that, we're going to start with demo number 1, and Shalaka is going to come up here and walk through the work that we've been doing from a Lambda perspective.
Hello everyone, I'm Shalaka. I'm an associate cloud developer with AWS, and as Paul mentioned, I worked on the UI piece for adding Lambda support to Spinnaker. And with respect to Lambda, we've done two major feature enhancements on Spinnaker. One is having Lambda as a target for an application load balancer, and the other is that you can have the full CRUD functionality for Lambda on Spinnaker, so you can create, update, and delete your Lambda functions to Spinnaker. So let's see how you can do that. I'll walk you through the demo. So we're into the applications of Spinnaker, and let's go to my application. I call it Lambda test. We have a new functions tab here. Let's create a function. Okay, I'm calling my function add vote function. And this is the same function that Paul is going to use in his demo. So I'm making it easy for him to use the function because I'm already deploying it for him. And this function is in Python, so I'm selecting the runtime as Python 3.6. And the code for my function is inside an S3 bucket. And the name of the bucket goes here. It's PR Spinnaker demo bucket. And the zip file that has my code, the name of that zip file, which is in that S3 bucket, goes here. And the function that has my code, the name of that function goes here. That is add vote Lambda handler. And I'm going to publish this function. And I need a role that my function is going to assume when it executes. And that role should have all the permissions required for my function. So I have it here. I'm just going to copy paste it into here. It's supposed to be an ARN, which is an Amazon resource name. And you can add environment variables for your function. You can add tags. So let's say team AWS. You can have a description. You can configure how much memory your function is going to need, the maximum time that your function is going to be alive in case it doesn't run. And then you can associate the function with a target group. You can add a VPC, subnets, and security groups for your function to be safe. And then in case you need some error handling, you want your Lambda function to report if something fails, in case there's a failure. So you can have either an SQSQ ARN or an SNS topic ARN in the dead letter config. So let's add one. And then if you want some monitoring and logging, you have X-ray tracing. You can activate it, and then you just hit create, and then boom, the function, let's see if it's created in the console. So there you go. The name of the function is appended with the application name on Spinnaker. This is like a cheat code here. And let's see if our function has everything that we put in. So we have the code here. We have the tag, the role, and the dead letter config. So this is how you can create a function, and you can see all the details of the function here. You can also go in and edit your function. So let's do that. Let's say we'll add an environment variable. So, and say description, put it inside a VPC with 2 subnets and a security group, say update. Okay, so let's check it out on the console. Let's just refresh this. So our environment variable and VPCs, and the description, and you can also delete the function. So just say delete, and it's going to ask you if you really want to delete your function. Hit delete. It takes a couple of seconds, and there you go. So on the console, it's deleted. And then another quick thing that we can do is associate a Lambda function with a target group. So for that, we need to create a load balancer, and this feature is only available for an application load balancer. So let's go ahead and create one. Let's call it demo ALB. And we don't want it to be an internal load balancer. Put a firewall. So the name of the target group here, you can edit it, of course. I'm just going to say TGP. And the target type is Lambda. So the UI changes a bit, and then we don't have a path with the default path like /health check, so it's just slash. And if we want, we can enable multi-value headers for Lambda. So multi-value headers are what the name says, HTTP headers which have multiple values for the same key, and forward it to the listener. And the target group is the name that we gave to the target group here, TGP. And just say create. Okay, so this is done, and let's check it out on, let's go here. And on EC2 console and under target groups, we'll see that our Lambda test target group is created, and under targets, we don't have anything yet here because we did not associate a function with the target group. So let's do that. Let's go back to Spinnaker under functions. We deleted the last one, so we'll just create one quickly. Okay. I'm going to keep the configuration exactly same. Let's give it a role. And a tag. And the target group name goes here. So our name was Lambda test TGP. And let's put it behind the same VPC and the same subnets, same security group. It's not a requirement though. And a DLQ. Just hit create. Okay, the UI on Spinnaker takes about 25 seconds to update. So meanwhile, let's go to AWS console and check. So we are in the same target group, Lambda test TGP, and when you see targets, there's our function. So when you hit the load balancer URL for this target group, this function is executed. Let me hand it back to Paul, and he'll carry it forward. Thank you so much.
Thanks, Shalaka. Thank you, Shalaka. That was great. All right. So that was the UI piece. We spent a lot of time working on that. There was a lot of details that went into that setup. OK, so imagine with me for a second. Now, we have a lot of customers that come onto AWS. And the first thing they say is, like, how do we onboard? What are we going to do? And so customers typically go through this lift and shift approach. Maybe they're running VMware, they have some other environment on-prem, and they want to actually move these assets over into AWS. So with that said, what's a great way to deploy applications on AWS? Well, that is Spinnaker, of course. So what we did was we have the first part where they're going to migrate over to EC2, of course. They're using VMs, so VMs work. I'm not actually going to bore you with the deployment of VMs because it takes a long time. However, you can see here is that I already have an application running, and it's already configured, and I can see it's sitting behind my load balancer. And so if I open this up, so what Shalaka did was she actually provisioned the Lambda code that allows me to vote on these applications. So again, here's a video of Jeff speaking. The other thing that's happening behind the scenes is that real time we're actually encoding some of these videos and we're pulling out interesting metadata. So like this was reInvent from a couple years ago of a guy walking. But so we're pulling out some interesting metadata with our ML service recognition. But anyways, the main takeaway here is that this application is now running on EC2. When I add these votes, it's actually going through and incrementing a counter in Dynamo, and it's being displayed here. And that was via the Lambda function that Shalaka was using for us, which is great. So Shalaka, thank you for that. So moving on with the same theme is that your CIO or VP of architecture, whomever, he went to a conference, or maybe he saw the Dilbert cartoon that we all saw, and the Dilbert cartoon said something to the effect of, if you really want to be working with technology, Kubernetes. Right? I don't know if you guys saw that. So now he says, you know what? I don't really want to be working with VMs anymore. I got to be working with Kubernetes. So what does that look like? So now what we have is we have a pipeline that we had created. Here's an old pipeline, so we can get rid of this. So we can take a look. In this pipeline, there's nothing magical here. We're just going to be deploying a manifest. There's going to be a manual judgment that we're going to execute. But so let's go ahead and run this. So we're going to start a manual execution of this pipeline. Let's say run. And this takes about 20 seconds or so. So what it's going to do, it's going to read through that manifest. It's going to grab a container from ECR, which contains a similar web app that you would have created. ECR is our Elastic Container Registry. So this could be like Docker Hub, but you could use other things, other solutions for where you're going to store your applications. So after this completes, we can actually take a look at Kubernetes here. And let's look at the pods. OK, so I can see 32 seconds ago, now I have a web app. But however, if I want to see if I have a service or anything associated, I don't have anything yet that's been created. And so the next piece is actually enabling this web app to expose an external IP for myself. I want to be able to access this web app just like I did on the EC2 side. So let's go ahead and hit continue. Now this next step in the pipeline is just saying execute this additional manifest that's going to expose a Kubernetes service that will now allow an external IP to be available and associated to my web app. So let's take a look at this real quick and see if we have an external IP that's given. Yes, so now I see a new DNS, a new host name, and this should just be about done. OK, let's take a look at the load balancer. And again, hey, here's my same web app. Now it's deployed using EKS, all working. I was able to do this quickly. So now fast forward, your CIO goes to a Gartner event, and they said, yeah, we're hearing Kubernetes is great and containerization is great, but we're hearing that serverless is the new hotness. So what does that look like? So with that, Allie's going to come up on stage, and she's going to run through and give a demo of ECS.
Thank you. That guy is totally not a plant. OK, so my name is Allie. I worked on the task definition artifact pieces in the ECS provider. And I'm going to try to show us a couple of things today. So the first is deploying, I don't know why to do that. There we go. The first is deploying an application to Fargate using ECS. The next is using the task definition artifact to define a multiple container application that I want to deploy onto ECS. And the final thing is to give you a little preview of an offering, a log router offering we came out with recently using FluentBit that will allow you to route your logs to multiple different destinations. So this capability will be available in Spinnaker in the next minor release coming up. So I think that's 1.18. So the first thing I'll show is I have and I am not used to working with a Mac, so apologies if I fat finger stuff this whole time. Okay, so the first thing I want to show you is I have a task definition that defines multiple containers. So here's what it looks like, and it's kind of small, but mainly what you want to take away from this is I have 2 containers defined here. One is the Nginx web application that Paul was showing off earlier. Thing to note here is that there's no container image actually in this file. This is because when the ECS provider launches your service, it will take the most recent image in your pipeline and put it in here in place of this placeholder. So the idea here is that you don't have to update your task definition every time you deploy your service. Spinnaker will take that file, interpolate the newest image that you've deployed, and push that to ECS instead. So the second thing to look at is I have a second container that is my log router. So this is using an AWS for FluentBit image that we vend that is using FluentBit and has a couple of plugins for CloudWatch logs and also Kinesis data streams built into it. So I'm going to use this along with my web app to route logs to S3. And finally, you can see I have a very important environmental variable that I need to deploy to this new application. So I'm going to try to do that now. OK, so I'll open up my ECS application, go to pipelines. OK, so let's take a look and see how the ECS pipeline is configured. So you can see I have a couple artifacts in here already configured. This is the existing version. And then this is the new file that I just looked at that I want to deploy to my pipeline. So for the sake of convenience and demoing, I have these as 2 separate files in here. But you could easily have just one file that you update with through version control. And so you could actually trigger your pipeline based on pushes to that GitHub repo, and it would take that file and deploy it into your pipeline. So that's something you could do, and we envision people doing with this. But for the sake of the demo, I'm going to just switch to a different one. So we have our new artifact configured, and I'm going to go to look at my ECS server group. So a lot of this isn't new, so I'm going to hand wave over some of it. But a couple things to take away. One, if you're using Fargate, which is our serverless container offering, a cluster in ECS is just a logical grouping of applications. So you don't have to actually launch any instances into it. Fargate's going to take care of that for me. So you see I have the Fargate launch type selected here. And then I have my artifact. So this is where I configure what artifact I want to pull my task definition from. And so for the sake of this demo, I want to switch to use this new one. Make sure I save my changes. OK. So now I'm going to go ahead and kick off a manual deployment. And I have this pipeline set up to trigger on pushes to an ECR repository. But I'm just going to select now which tag I want to use. Now this usually takes a minute, so hopefully luck is still with me today. And so now it's deploying to ECS. Oh, there we go. So I have a new service that kicked off in ECS. So let's go see what this looks like. OK, so you can see here's my ECS cluster. I have one cluster running. You can see I have 2 services running, but I don't have any container instances. So I didn't have to provision any EC2 instances to get this to work. So let's go look at the services in here. So we can see our most recent one that just got deployed is here. And then here's the old one. So what's happening is Spinnaker is spinning up a new ECS service, and it's going to drain the old one behind the load balancer. So it'll push up the new one, or it'll deploy the new one, set its desired task to 1, and then later on it's going to drain this one, so we only have our newest application running. So cool, so I have my service running. Now let's see if I didn't screw up and select the wrong one that I've got. So here are this is my task definition that was just registered with that file. I have my 2 containers, and let's see. Oh, here we go. My very important environmental variable was updated. So this service did pull down the latest file that I told it to look at. So cool. So I know that this service is running in ECS. But what about, are my logs still persisting where I want them to? So let's take a look at S3 to make sure my logs are still going to where they need to. So FireLens has routed my logs using Kinesis data streams into S3. And I set this prefix so I can identify the folder it's sending stuff to. We'll just go to the very latest one. And let's refresh. OK. So yeah, so it's not going to be very exciting, but we will, if we look in this file, we will see ELB health checks that have been hitting that web application. So let's just open it and make sure it actually has things in it. Cool, so there we go. So routing to S3, like I can't do a whole lot with it just in this format, but FireLens really enables you to route logs to where you want them to go. So anywhere you would be able to route your logs to with Fluent Bit is something you could leverage through this. And the real value add of FireLens is that if you use this through ECS, you don't have to configure, you don't have to version a configuration file for Fluent Bit on your own. So we wanted that capability to be right in the task definition for you. However, if you want to use EKS or something else, you can totally use the AWS vended image for Fluent Bit that we have and leverage the plugins that are built in. So cool. So my logs are there. I deployed with an artifact. I'm on Fargate. Now let's see and make sure that the web app is actually running. So full disclosure, there is a known bug in the Spinnaker UI for the ECS provider that doesn't make it so easy to see the load balancer. But I'm going to prove to you that this is running, so I'm going to navigate to it through the AWS console. All right, we got that. We have a DNS. And there we go. So there's our ECS web service deployed. And that is all I have for you. So hopefully you had some good takeaways, you see some stuff maybe you didn't know the ECS provider could do. But yeah, thank you very much for your time.
OK, so I know we have about 5 minutes. If there's any quick questions, happy to take them now, or you can just come find us a little bit later. Please.
On the deployed, is it anticipated that it's going to be sidecars on deployed applications, and that's just sort of the model for log publishing through FireLens? Is that how that works?
Speak to like far into the future what the different iterations of it might be. But yeah, the idea is that you could run a sidecar Fluent Bit container, and then ECS will do some of the handling of configuring that for you, depending on what settings you use. But yeah, that's the idea.
And I had a question regarding the Lambda's support. Had you at least contemplated enabling the feature to be able to first pull Lambda artifacts from like an artifactory or something, publish them up in S3, and then proceed to the next step? Or is that something that, that's probably the sort of step that could be a custom stage or something like that? But I'm just wondering if you'd pulled that thread at all. Oh, as in to get Lambdas, the zip files for Lambdas that are stored in like a private artifactory or something like that, and then published up into S3 as part of the deployment process.
Yeah. So. Yeah, so I think the question is, from a pipeline perspective, is like, can we do the pipeline integration? And we realized that we wanted to get the UI work, the initial UI piece done, but then the next phase is like updating the pipelines. I think one of the key takeaways is what Armory did in the knowledge base article that I wrote earlier, is that they are following a workflow similar to that. But we hear you loud and clear. It's something that we need to look at and enable in the future. Oh, yeah, no problem.
I have a question on the functions. Is there an API to create those, or is it only via the UI?
You can absolutely use the API, and so we have, if you go to the Cloud Driver page for Lambda, you'll see the full documentation on the various API calls that you can make to create and do full CRUD functionality and actually execute your functions as well.
Hey, so at the beginning you mentioned about dynamic pipelines using Fargate.
Yes.
Yes, so I wasn't.
So do you want to talk to the artifacts and like what the artifacts enable you to do?
Yeah, I guess I'll stand up. So I think implementing the artifact functionality was a way to have you version not just your image that's working its way through the pipeline, but also any other metadata you need to run that application. So I think when he mentioned that, he was speaking to the fact that now you can version that entire application through artifacts and use that in your pipeline as well, instead of just pushing the image through, which is the main piece of work that the ECS pipeline is going to do. So I think that's really the dynamic piece now, is now you can use artifacts to sort of deploy and version all aspects of your task definition as opposed to just the image.
So the hydrating with different values is what the dynamism is.
Yeah.
Okay, thank you.
Okay, any other questions?
As regards the ECS service support, I didn't see in the UI there things like auto-scaling rules and things of that sort. If people wanted to sort of add those in, is that is that again like an extra stage where we would terraform them in or something like that? Or do you have any thoughts at this stage about how best to integrate that kind of thing?
We're aware there are gaps in your ability to configure, are you talking about task auto-scaling? Yeah, task auto-scaling rules and policies from within the UI. What you can do today is if you have a service that exists and it has your auto-scaling policies on it, when you can configure it that so when Spinnaker deploys to that service, it will copy over those existing rules to the new iteration. So it's not a perfect solution, and that's something that, that's a gap we know we need to address. But right now, if you create a service, you set it up once, through the ECS console, or the EC2 console or through the APIs, then all your subsequent deployments will leverage those same policies. So you can retain what you have, but the ability to create them from scratch is not there yet.
Okay, fair enough.
Hi, I have a question about the Lambda runtime. So during the demo, I saw a drop-down. Is that dynamically pulled from AWS, or is that list? Because AWS constantly keeps changing the list of runtimes, so how do you plan on keeping up with it?
Right now, it's just a list on Spinnaker because we don't have an API to pull the list of supported runtimes.
We struggle with that too.
So, yeah, we'll have to talk to the AWS Lambda side to make that API available.
Yeah, so just if you can't hear, to answer the question is that today we hard-coded in the list of the various runtimes that we support, and so in the future we need to work with the Lambda team to be able to pull that list to get a current list of the available runtimes, and then put that into the tool, the platform.
Sure, thank you.